Hello, everybody. I'm in the Angle Measures tab of your flipbook from question number 23. This is part two of a lesson that I like to call four phrases. In the previous video, I did the problem types for cross multiply and outside times whole. So note here, angle 1 is sort of in a random location. If it was in the center, we learned that central angles are the same as their arc, so it would have been 153. But this is not perfectly in the center. If it was an inscribed angle, it would have been half of 153. But it's not inscribed. To be inscribed would be like this, where this is on the vertex is on the arc, and if there was 153, we would just half it to find this. So what happens is when you don't have either, you just simply take the average of the arcs. And when things are pretty simple in this one, you're given the arcs that you need. So angle 1 goes with the 153, hence we did with the colors. And on the other side is the same as angle 1, it goes with 105. And you're just averaging the different arcs. To average is to add them up and divide. There's two of them. And so that would be 258 divided by 2. I believe that's 129 degrees for that angle. Definitely an obtuse angle. 129 looks good. So getting that one straightforward. Sometimes, though, your pieces that you need, they are missing. We're looking for the measure of arc KM. So I'm going to put an X over here. Now, it goes with this angle, which goes with this angle, which goes with this 67. But 133 doesn't help us with X. 133 helps us with this. Where 133 does save us, though, is the fact that on any straight line, it's always going to add up to 180 at any vertex. So 47 is going to be this angle and this angle. So remember, I'm taking the average of the arcs. Well, what exactly are the arcs? Well, here's the arc is 67, and here's our other arc. So 67 plus X divided by 2, because I'm taking the average of the arc, and it equals the angle. The angle is 47. So if you watch your equations video and you know how those work, this is a pretty good one off of there. Get rid of divide 2 with the times 2, and I'm left with 67 plus X equals 94. Get rid of positive 67 with a subtract 67, and I believe that is 27. It makes perfect sense. If you average 67 and 27, you will get 47. Take the average. So again, I like to just use these phrases as opposed to what's in the book up here, though they're literally just saying to find angle 1, you would add arc AB and CD and divide by 2. If you're looking for angle 2, you would average this one and this one, because they go with angle 2. Down here is our final phrase, and again, rather than remembering these statements, I come up with phrases to help you. So speaking of which, I'm jumping to 26 for a reason. The phrase here is the big arc minus the little arc divided by 2 still equals the angle. Not to be confused with we just did big arc plus big arc, or we just did arc plus arc divided by 2. We just averaged the 2 on the last one. So be careful not to get confused or get it backwards. If you do get it backwards, you're going to get some strange answers. Anyways, now note, the arcs that I'm talking about will always be in between these two lines that go through circles. They're called secants. So the big arc is indeed 141, and the little arc is 25, and I divide by 2, and that'll give me my angle, which is E. I'm looking for angle E. I could put a little X in there and call it X. So simplify that. You don't even got to solve, and you got it. 25, the reason I'm kind of skipping it here is because though you could take the average of these two arcs, and you don't have hardly any arcs, it's just easier to use the inscribed angles rule, because this is an inscribed angle. It's a really big inscribed angle at 138, Remember, for the arc, you times by 2, which puts us at like 276. Now, every circle is 360, so there must be another 84 for this arc. And I could take half of 84 and find out that this inscribed angle is 42. And look at what happened. We got a straight line, and it's adding up to 180. So, looks like I did that perfectly. Geometry rules will verify themselves oftentimes. Last two. So sometimes, again, in geometry problems, they take numbers that you need and hide them from you. So if I ask you, what's the big arc? Or what's the little arc? The little arc is the 89. Remember, we always got to deal with arcs that are in between our secant. So the big arc is this up here. And we don't have it. It's hiding. But remember, every circle in the world has to be 360. And our circle is broken up into 3 arcs this time. There's an 89, there's a 52, and whatever's left over for that other one. And that's 219 for my big arc. So again, this is a big arc minus little arc divided by 2. And these are generally some of the highest questions on the test, these big arc minus little arc questions. 219 minus 89 divided by 2 will equal the angle. The angle is 4x plus 1. So no, why did I not use the 52 as the little arc? I've always got to use arcs that are in between my 2 secant lines, and 52 is on the outside of it. It helped me find the 219. Subtract this, and I'm down to 130 over 2 when I subtract that, and go ahead and divide it to get to 65. And it's pretty easy two-step equation from this point. Subtract 1 is 64, and divide by 4, x is 16. And then finally, on the last one, you only got 1 arc, whereas over here you had 2. But this circle is only broken into 2 pieces. So the missing piece, the big arc, must have been the other part of 107, the other part of the 360, which will take me to 253 for the big arc, if I subtracted that right. So now I can do big arc minus little arc divided by 2 will equal the angle, and the angle is just x. That's what we're looking for, angle Q. So 253 minus 107 divided by 2. So that one's already solved. We just got to simplify it. And you get 73. So now that we've reached the end of that, the great thing to check is making sure you know when to do which phrase. Like, out of the 4, A, B, C, and D, do you know which one is cross multiply? Maybe pause it, think about it for a second. Hopefully you said C is cross multiply. That would be 9 times 2 equals 3 times x. Next up, do you know which one is outside times whole? Maybe pause it, think about it. Now, although B and A look the same, only A has outside times whole pieces. Outside would be 5, the whole thing would be 11. On the other line, the outside would be x, the whole line would be x plus 8. Now, next up, which one would be taking the average of the arcs? Think about that, maybe pause it if you need to. Well, taking the average of the arcs would be D. If I want to find x, it's random, it's not in the center, it's not inscribed. I simply average the 50 and the 60, which would be 55. And then finally, B is your big arc minus your little arc divided by 2. And that's that. So the first warm-up word quiz is, all I'm going to ask you is, to match the phrase. I'm not even going to ask you for the math part on that. This will be a good focus for 2 days in class. Thanks so much for watching.